Good morning. So we're going to be going a little deeper into this integration, I guess, operation. So this is I'm calling this presentation the power of U. I want you to remember this U substitution. It was really useful before. It's going to be really useful now when we get into more complex integrals. So this is the general power rule that you know. You've been introduced to this before. You have the integral of x to the nth power with respect to dx is equal to x to the n plus 1 power divided by n over n plus 1. That's just so when you take this derivative, you end up getting that 1 in the front of your integral plus c, where n is not equal to negative 1. The reason why this n can't be negative 1 because x to the negative 1th is 1 over x, and that is a very, very special integral that we'll be getting into later. You could probably figure that out by thinking about what is what derivative or what function has a derivative of 1 over x. Okay, so sorry. There we go. So consider how you would find this antiderivative now. So I'm going to give you something a little bit more complex. I have 2x times x squared plus 1 to the third power. Okay. So because you're hunting to find a function whose derivative is 2x times x squared plus 1 to the third power, you might discover this to be difficult, but not impossible. The key to this solution is that 2x factor. This 2x factor is actually something related to this function here. Okay, so if we were to find this antiderivative, that the key here is that this 2x factor is the derivative of this inside function here. Okay, so this is a key that we have a chain rule happening here. Okay, so we can use our friend U substitution to help us better understand this complex integral. So this is what we are aiming to solve. I have this integral of x squared plus 1 to the third power times 2x with respect to dx. That's going to be equal to u to the cube du, and we'll go through how that is how that will be set up in the next slide. Okay, so here, this is what we had on the last slide, this statement, where we have u is equal to x squared plus 1. We can think about the u as what's being plugged in, right? The same way that we would look for u that is plugged into a parent function when we were taking differentials. Now we're going to be looking for what is being plugged in to an exponent or another function here. We're looking for a composition of functions, which is the same thing that we were looking for when we were doing a chain rule. Now, the derivative of u is 2x dx, right? Because we have to take into account that we're not differentiating with respect to u anymore, but with respect to x. So we have 2x dx. Now, du is also present in my integral. So that's how I'm able to make this substitution. So I have u to the cube, because I have x squared plus 1, which is u cubed. So I'm going to write that in my new integral, just making a substitution. And then I have 2x dx, which is equal to my du, so I can make the substitution now. So this is actually a lot easier to solve. We can use a simple power rule to do this. We add 1 to our exponent, and then we divide by this new exponent as a coefficient. So I have u to the 4th divided by 4 plus c. And then if I check my work, u to the 4th divided by 4, I bring the 4 down. 4 divided by 4 is 1. So that's what I want, my coefficient. And then 4 minus 1 is 3. Okay. Now, the last thing that I would need to do is just to substitute these values back into my problem. So I'm sorry I didn't write that down here and I show it to you on the other examples. This answer would be x squared plus 1 in parentheses to the 4th divided by 4 plus c. You always have to make sure you do that last substitution, and you'll see that on the further slides. Okay, so this is the general power rule for integration. We have the integral of u to the nth power du dx with respect to x. Now here, I want you to understand that this here, du over dx times dx, is just equal to du. You will have a situation where you will have a elimination here. So you don't need to write that. That's just there for you to understand. So now I have the integral of u to the n power with respect to du is equal to u to the n plus 1 power over n plus 1 plus c. This is my simple derivative rule, but instead we just have respect to u now instead of respect to x. Okay, so don't get super confused on that one. Okay, so when using the general power rule, you must identify a factor u of the integrand that is raised to a power. So this only has to do with, obviously, powers. Okay, then you must show that its derivative du dx is also present inside of the integrand. So that's this, what's being plugged into this integral command. Okay, this was demonstrated in the example on the last slide. 2x dx is the derivative of x squared plus 1, because we know if we take this down, we'll get 2x, and then we have dx with respect to x. Okay. Now, so we're going to do another example. This one has a square root in it. Don't get scared by the square root. So the first thing you're going to do is identify the u and du within the integrand. So this is the integrand. Remember, the integrand is what's being plugged into the integral sign. Okay, so that's what's being plugged into the integral sign. So for example, I'm looking for what has an exponent. The square root is an exponent. It's just hidden by a shape. So x cubed minus 2 is my u. Its derivative is 3x squared dx, which is right here. Okay. When I organize my new integral, I'm going to move this 3x squared over to the dx, so that way they're together, so it's a little easier for me to look at. Okay, so you see how I moved it over? So now I have my du here. I tried to color code it so you guys can see. And then I have my u being plugged in here. I wrote this as a 1/2 because it's easier for me to think of algebraically of what the integral will be with that. Okay, and then my last step is to integrate. I'm using a simple derivative or simple integration rule. Sorry, 1/2 plus 1 is 3/2, and then I'm going to be multiplying that by its reciprocal for my coefficient to make sure that when I take the derivative, I have a elimination and I always get that coefficient of 1, which is what I want. Okay, so that becomes 2/3 times u to the 3/2. Just to check my work, if I multiply 3/2 times 2/3, I get 1, which is what I want, which is my coefficient in front here. Okay, and then I substitute u back into the solution. So this is my final solution. Okay, now last problem. Oh, did I? Oh, add an extra slide. Sorry, guys. This is one more problem. I just had a double of the last problem. So we're going to go back. We're going to identify u and the du within the integrand. So we want to make sure that we're looking for the u that has an exponent. It's being raised to something. So the u here is x cubed plus 6x. Its derivative is 3x squared plus 6. That's right here. Okay, there's our du. That's what we want. Okay, and remember that dx is part of this du. You see how the dx is inside the du? So when we do that substitution, the dx goes away. Okay, and now we're going to substitute this into the integration statement. I moved my derivative piece over to be next to the dx, so that way it's a little easier for me to see my substitution. So I have x cubed plus 6 squared, and then 3x squared plus 6 dx. This is my du statement. It's highlighted in green. And then this is my u statement, highlighted in purple. Okay, and then I integrate. I have u squared plus d, or u squared du is equal to, the integral of that is equal to 1/3 u cubed. Just to check, I take my 3 down. 3 times a third is 1, which is what I wanted, plus c. Okay, and then I substitute the u back into the solution. So I have x cubed plus 6x to the third power divided by 3. Now if I did this derivative, just to check my work, 3 times 1/3 is 1. And then I would have to take the derivative of this inside, which would be 3x squared plus 6, which is exactly what my integrand was when I started. Okay, you guys have 2 practice problems. The way that this work is shown is completely valid and welcome. Please, please, please feel free to comment, email, text, anything with question, comments, concerns, issues. I know that this is a lot. I feel like you guys are going to have a pretty okay time with this because some of you guys are very good at algebra. Some of you guys did a really, really, really good job with u substitution when we use it for differentiating. So please, please, please take your time with it. Feel free to reach out. Also, you could also hit me up on my Instagram. It's dope, DOPE .slopes, SLOPEZ. Amir hit me up on there yesterday, and he got an answer within probably 2 minutes. So please, please, please utilize that. I'll talk to you guys soon. Have a great. Oh, now I gotta turn you off. Da, da, da,